So now we'll move on to our next talk, and for the next talk we have Sandesh Mysore Anand and Ashwath Kumar. So the talk is on preparing for D-Day, evaluating your organization's preparedness for the most common attacks on your cloud infrastructure. So I'll quickly introduce both Sandeep and Ashwath before we proceed to the talk. So Sandesh is a senior security engineering manager at Razorpay. So he manages the security team at Razorpay. So over the last decade, he helped companies to build and mature various aspects of the security program. And Sandesh is passionate about application security, cloud security, and working with engineering teams to incorporate security into their products. And in his free time, he also writes infrequent newsletters infrequent newsletters are good insights in that. And he'll also, love talking about food and cheering one of his favorite sports teams in the free time. So that's about Sandesh. And we also have Ashwath Kumar. He's working as a staff engineer at Razorpay. Previously, he was with Synopsys and Microsoft. His interests include red teaming, application security, and threat modeling. He also has released plugins for Burp to handle complex authentication mechanisms. He's also a speaker at various conferences, which include both national, international, and the conferences that were run by the companies that include RootCon, NullCon, KubeCon, etc. So, welcome Sandesh and Ashwath to present the talk. So yes, so this talk, specifically for this one talk, we already have the talk done, both Sandeep, thanks to both Sandeep and Ashwath. We have the recording now and we'll play that. And Sandesh is here in case if you have any questions, do pop it in the Q&A channel or the chat channel. We also have a Discord channel. Uh, I'll just paste the link in the chat box. You can join over there for a conversation as well. So yes. Cool. Over to you, Nikhil.
Sure. Thanks, Nal. Let me quickly share my screen. Let me know if my screen is visible as well as the audio.
Your screen is visible.
Okay, cool. So good morning, everyone. Thank you for inviting us, to ThoughtWorks SecConf. Really excited about all the talks lined up for today. So my name is, quick introductions. My name is Sandesh Mysore Anand. I am a senior engineering manager at Razorpay in the security team. I'm also joined today by Ashwath Kumar, who's a staff security engineer at Razorpay. Both Ashwath and I, have been working with Razorpay for a while now, and we work closely, with all aspects of security here. Okay. Just want to start off by telling you a little bit about Razorpay, just setting the context a little bit. If you made any online payment in India, you probably use Razorpay, right? Because many companies, about over 10 lakh businesses in India, rely on Razorpay to power our payments. And some of the logos here are, I'm sure, things that you've heard of, companies you've heard of. Want to tell you a little bit, given kind of the theme for today, I want to talk a little bit about what scale means for Razorpay, right? Over the last 4 years, we've seen over 10x growth in our headcount, right? In the engineering group, which means that a lot more people writing code, a lot more people shipping code, right? This is kind of shown in the bottom right thing you see as well, is that we do approximately 2,000 deployments per month, which means dozens of deployments to production every day, right? In addition to like scaled up teams and pushing through a lot of code, we also have a polyglot stack of many different programming languages. And finally, we've also acquired companies of late, which means that we have to ensure that we don't just think about the code we write, but also of the companies that we've acquired. So this should give you a sense that essentially whatever security program we build at Razorpay, it essentially has to account for scale. And if you don't do that, it's hard to be successful. So keeping that kind of context in mind, I want to talk about what keeps security up at night, right? Now, obviously, there are many more attacks than just the three that I've listed here, but these are the three things which really kind of keep us up at night, right? So let's kind of set a stage a little bit about what each of these are. So first, DDoS or distributed denial of service attacks. This is essentially when when a botnet or a bunch of machines send you traffic, right, from different machines, right, which is a lot simpler these days because of botnet. Right, so you don't really need to build a botnet, or you don't need to really need to compromise a bunch of machines. You can buy compromised machines off the rack, right? And then essentially what you do is that you coordinate attacks from different legitimate machines which are compromised, right? Which makes it very hard to kind of apply old school blocking rules, right? Because they are legitimate machines, they're not necessarily attacker machines, right? And finally, the scale of distributed denial of service attacks are growing like crazy over time, right? I think recently Cloudflare put out a report which basically spoke about 17.2 million RPS was the scale of an attack, right? So that was the amount of traffic coming through on a single attack, which means that you need to really think about what each of your service or each of your applications can take, and then think about what scales coming up in these attacks, and then figure out how you will manage the delta or how you will prepare for it, right? So this is getting increasingly complex over time, and the nature of the public cloud is such that a lot of our systems are accessible through the internet, right? Which means that the attack surface the attack surface itself has grown larger and larger over time. We are an online first company. All our critical assets are online, right? That's how our customers access it, right? Which means that the attack surface is large as well. The second thing that keeps us up at night is data exfiltration, right? As you can imagine, powering these many businesses mean that our customers trust us with some of their sensitive data. In addition, we also use data to kind of make decisions, right? To make decisions to make product better for our customers. Losing this data not only erodes trust from our customers, but it also kind of has regulatory implications, right? And given our success and given our scale, there's a large market for data, for our data, and for other companies which are similar to us as well. There are innumerable attack vectors for data exfiltration, right? There are many different ways from which you can launch a data exfiltration attack, etc. And we'll talk about some of that later today as well. Finally, ransomware attack. This is in the news. All of you have heard about it a lot. Interestingly, the attack vectors for data exfiltration and ransomware are somewhat similar. The starting points on how the compromise actually happens, but what happens after that completely different in whether it's in a data breach versus a ransomware. The motivation is very different as well of the attackers. We'll not talk a lot about ransomware today because I think the defense strategy, is there are some technical aspects to it, but there's a lot of non-technical aspects as well. And maybe we'll talk about that on a different day. But these are the three things that really keep me up at night, or keep us up at night, and we always think about how do we what kind of a strategy we should apply for these attacks, right? So, we have a simple framework to kind of, managing these threats, right? I just want to be clear. I know there are like 100 frameworks out there. Everybody from NIST and RBI and all the smart people in the world have come up with different frameworks. But we kind of believe in having like simple frameworks to start with, and then over time, kind of, add nuance to it based on how things happen, right? So, a simple way of thinking, for managing critical threats, right, like DDoS, data exfil, etc., is to kind of think of detect, respond, and prevent, right? So, when an attack happens, early detection is everything, right? Detecting an attack within a few seconds or within a second or so, a DDoS attack within a few seconds is the difference between a blip, a little bit of a blip here and there versus an absolute disaster, right? So the first few minutes, the first few hours, depending on what kind of attack we're talking about, can make all the difference, right? So early detection is very, very important, and you need to build your systems to kind of be ready for that. Second, your response to attacks cannot be theoretical; they have to be battle tested. You have to have you have to be prepared on how you'll respond when an attack happens, right? You obviously have systems to prevent these attacks, and we'll talk about that as well. But you have to assume that these preventions will sometimes fail, and when they fail, you want to have a plan in place on how you will respond, right? That's on response. Finally, prevention obviously is the most important. You want to set your systems right. You want to set your systems in such a way that these attacks don't succeed. Right, and the best way to do that is to kind of obviously follow all the best practices and all that. We'll talk about that, but also to kind of get the data from the attacks that are happening and continuously improve over time. So what's really important is that there's a feedback loop between each of these states. Now, this framework works well, but there are some challenges that occurs with scale, right? So when we were a much smaller company, it was much simpler to do some of these things. And there are certain complications which arise only when the company grows, right? So one is that, your detection, your dashboards on, so the way detection usually works is that, you kind of identify patterns which look like attacks, right? Even if you're not sure if they're an attack, you kind of monitor on those patterns, and then you alert on, alert when that pattern matches, right? At a very high level, that's kind of how detection works. And it becomes really hard to do detection at scale because you need to apply to all assets, right? Where attack is possible. Now, even knowing what all your assets are is complicated at scale, right? Seems simple, but it's pretty complicated. We did a talk at a different conference on this. We'll link to that if you're interested to talk about how we kind of think about asset management, asset inventory, etc. But when you're acquiring companies and you're doing 2,000 deployments a month, knowing exactly where all your assets are and adding monitoring and adding alerting and detection on that, itself can be a challenge. Clear, right? If when an attack happens, obviously it's that shows that people care. But the problem is that if you have too many cooks kind of managing your response strategy, it can muddy up waters. There's no clarity of thought, etc. So clear ownership on who's doing what is very important when you're responding to an attack, right? And too many cooks can really spoil the dish there. Finally, in prevention, when things happen at scale, you can it really becomes difficult to kind of figure out layered prevention. What I mean is, there are controls, let's say rate limiting, right? So that can be applied at many different layers, right? You can apply it at your WAF layer, you can apply at your edge or your API gateway, or you can also do it in your applications themselves, right? So just thinking about ownership, who needs to do it, what is the right place to apply these strategies itself becomes quite challenging. This is not very hard when you have only a few applications or you have a few owners, but when you have a large company like ours, when you're scaling rapidly, these kind of decisions become really hard to kind of think about. Okay, cool. So now that we have this, let's start talking about data exfiltration, right? So we'll talk about data exfiltration first a little bit, and then move on to DDoS, and then we'll wrap things up. Okay, so we spoke about data exfiltration, basically, losing your, your sensitive data being leaked, right? Sometimes also called data breach is probably the more common terminology here. And before we get into kind of like defense strategies, just want to establish that, if you want to think about two key attack vectors, right? One way to think about it, there are many different ways to kind of classify this, but the way that we like thinking about it is one is you have a compromised or a malicious user. Think of a user who's a victim of social engineering attack or a phishing attack. A recent attack on a cab hailing company is a good starting point there. Or you have a malicious insider, right? Disgruntled employee and so forth. Now, like I said, right, you don't want to assume that you have disgruntled employees. That's not a nice place to be. But the reality is that as you scale, the law of large numbers apply, and the chances of having a disgruntled employee grows, right? So you want to kind of consider that as well. But really, compromised users, are really our number one threat actors there. The second thing is the compromised application, right? So you have a vulnerability which leads to an RCE, which leads to control of a machine, and then you kind of, one of the things you want to do from there is to go and steal data that application has access to. Right. So this is another attack vector. And finally, of course, misconfigured consoles. I mean, I think there's enough jokes about MongoDB, public MongoDB, etc. out there. But the reality is that in a cloud-first world, if you misconfigure your infrastructure, you need access to data. Something to do. So these are the two key attack vectors, and we'll talk about slightly different strategies for each of them. Okay, so countering compromised users, right? So let's say, so again, we want to, in the way we think about it is that there are really three steps, when you want to stop data exfiltration. Like I said, this is the framework that we use. There's, not all frameworks are perfect, but some are useful, right? So this one's for us a useful framework, right? So there are three things that needs to be done, right? One is you want to minimize clear text storage. Okay, so if you talk to like data privacy folks, they'll always talk about storing only what is required. They'll say, hey, the simplest ways to do privacy is to kind of like store as little as possible. Now, that's a complex discussion to have with engineers and with product managers, etc. But in general, it's a good idea to store only what is required. And I'll split this into two parts, right? So one is like consciously storing only the data you need. That's one. But secondly, also being conscious about what you're storing, right? Because sometimes what happens is, developers tend to just store everything, right? Everything that comes in, just log everything that comes in. You may need it later for debugging, etc. Right? So that can happen, and there are legitimate reasons for why developers do that, but we need to work with them and evangelize and talk about kind of storing only what is required, right? And also giving them tools to help out, like having a logging library which kind of detect if you're storing sensitive data, and blocking it, that layer is actually like a good tech way of kind of solving the problem. Now, even if you store only what is required, sometimes things get through. So it's always good to kind of like mask sensitive data. So if you have like data stores, if you have like a data lake, it's useful to kind of think about having masking strategies, right? Usually, most modern tools, like the ones we use for sure, have ways of detecting sensitive data at the ingestion layer. So even before the data goes into your log aggregator or your data lake, you can make sure you mask the data, right? So that way, that way, even if a developer makes a mistake, it doesn't like go in, right? Now, having said that, this is also imperfect, so you want to make sure that you don't have a single strategy there. Third, of course, is that if you have to store sensitive data, consider hashing it, encrypting it, tokenizing it. Again, depending on what kind of data we're talking about and what the use case is, there are different strategies there. But the idea is to minimize clear text storage as much as possible. This will make sure that even if there's a compromise, at least the damage is limited, right? So that's one, right? So the second thing which is really important is to kind of enforce the principle of least privileges, right? We've all heard of them, right? So at a very high level, I'm not going to spend too much time on this, but at a very high level, if users need access to data, obviously, right? But enforce to make sure that you use SSO, so for authentication. So this allows you to kind of makes it much simpler to do things like offboarding, right? When people leave the company. Also helps you when users generate like API keys, it can be tied into your SSO. Again, when people offboarded or when people role change, it's a lot simpler to manage. Using RBAC or ABAC, is obviously useful for authorization. Now, this is an entire talk on its own. There's a lot more nuance and detail and complexity to it. But in general, I think for this talk, we'll stop at saying that definitely use some kind of RBAC or ABAC that works for your company. And finally, things go wrong, right? So doing access audits is really important. Kind of make sure that you're looking at who has access to what at a regular basis. This is not just who has access to what, but also think about who accessed what, right? Somebody downloading data once is very different from them downloading like 1,000 times. So what happened there? So just looking at those is kind of useful. And finally, to stop data exfiltration, again, this is generic advice. Doesn't always work everywhere, but to get useful lens to look at. One is you want to have hardened laptops, right? Just make sure that people can't exfiltrate data physically through the laptop. Finally, secondly, think about like sandbox solutions like VDIs, for example. Again, this may or may not work all the time, but there are situations where this works, especially if you're working with third parties, etc. Where you sandbox where they can use it, and you harden that VDI, which makes life easier. Finally, data loss prevention. Again, much like RBAC, this is a whole 1 hour talk on its own on the different layers of DLP, etc. But in general, having a DLP solution which looks for data being exfiltrated is very helpful, right? And these are some strategies which help with compromised users. So now let me hand over the mic to Ashwath, who will talk a little bit about countering compromised applications and also talk a lot more about DDoS. Ashwath, over to you.
Sure. Thank you, Sandesh. Again, I come from a red teaming background, so I spent quite a bit of time in red teaming during my journey at Microsoft. So if you think about red teaming, right, there are 3 phases on how an attacker could get in. So the first phase is the initial compromise, and the second phase is lateral movement, where you try to do some elevation of privilege. You go from one meeting to another, one user to another, and so on. And finally, there's a third step so this is like the exploitation, right? So this is where both data exfiltration could come in, ransomware could come in, and so on, right? So specifically talking about, a malware or some kind of a compromise on the container or on the instance is what we're going to focus here on. So the first piece, Sandesh did talk about it. So this is a conflict that we usually run into, right? So data is the new oil. So the data science folks and the product analytics folks, they want as much data as possible. So how exactly do you write that fine balance? So this is where like automated tools come into place. And for really mature companies, they have tokenization where they will still enable you to store the data, and at the same time, kind of secure, right? So that's basically, what the first bucket talks about. So when it comes to least privilege, specifically in the cloud scenario, I'm going to use AWS as an example here, because Razorpay is mostly like an AWS shop. So, when it comes to IAM roles versus secrets, IAM roles are more preferred because you can do fine-grained policies on, okay, this particular role, you get access to these secrets, and, the kind of access is going to be like a read access or a write access and so on, right? and you can restrict it to a bucket level and so on. And there are automated tools, for example, like CloudSplat, which will run and it will tell you if there is a particular role which will give you S3 star and with complete access to everything, right? So there are multiple automated tools which will kind of do an access audit on the first piece. Then the second piece is on the restricting roles. So this is also more on to say, okay, give access only to the bucket that's required and not to all of the instances, right? So for example, if you take S3, don't give access to all of the S3 buckets. Just give it to, let's say, for example, the prod alerts, right? So just give it to that particular S3 bucket. Then finally, audits, like Sandesh mentioned, audits can be performed on a regular basis just to identify the access patterns, and if a particular application is trying to access all of the S3 buckets instead of just one bucket, then something's going on, right? So you could potentially set up alerts on those anomalies. Again, this is the work that we've kind of started on this. We don't have we haven't completed it fully, but this is something. These are the angles that we're thinking on. So this is to mostly on the detect phase. Right. So to stop data exfiltration specifically, the things that we are looking at is specifically on the detect phase, the Route 53 resolver logs. So most of you might have some kind of a threat intel platform. So we use MISP along with our own feeds that are coming in. So specifically, since we're in the financial industry, we use FSISAC, which is supposed to give us feeds from other financial institutions. And also these are mostly triaged feeds, right? So we hook this up with the resolver logs, which will kind of tell us, okay, what are the bad domains that are getting resolved at the DNS layer, right? So this we could pipe it back into the DNS firewall. So that is number 4. The AWS has also written a blog on how exactly do you pipe from guard duty to the DNS firewall. So this is something that can be done. So then finally, the network firewall piece. So this is number 3. This is the response. Also, there's a blog on guard duty to DNS firewall, wherever there is a bad IP that's being accessed on the egress layer. That is the outgoing traffic. Just try to catch it, right? So basically, summarizing the slide, focus on the least privilege. Also, just log whatever is whatever is required. Focus on the least privilege, and on the data exfiltration, start collecting analytics on what domains are being resolved and what kind of IPs are getting hit, right? So then you can set up automation to kind of take inputs from multiple threat intel feeds and go to log stuff. And more importantly, it's good to understand what a clean blueprint looks like. So for example, what does the egress traffic looks like for a particular architecture, right? So that is very critical. So that will give you an understanding as to whether, my environment is going and talking to a lot of IPs or just one specific IP, right? So that will kind of help with the situation as well. Next slide, please. So DDoS, right? We've spent quite a bit of time, hardening our systems against DDoS attacks. Because we took up availability as a goal, and we said, okay, fine. DDoS is one of the biggest problems for availability, where it can cause an outage which could lead to an availability issue, right? So next slide, Sandesh. So what exactly is a distributed denial of service, right? So if you think about, the green traffic is like the normal traffic that needs to go through, and the red traffic is like the attacker traffic coming in, right? So for example, we could have 10,000 IPs. All sending 20 requests per second, all at the same time, right? All at this particular instance to say, 5 p.m., 10,000 IPs, all of you send 50 RPS or 100 RPS all at the same time, right? So it come choke the system. And the most affected parts are usually the databases or, queues and so on, right? So these are the systems that can take time to do the writes. And this is where the system could become corrupt, and recovery could become a big mess if the systems are not architected well. So how do we want to kind of prevent against DDoS attacks? So the very first piece that you need to go back to is have a good inventory of all of your applications, right? So for websites, specifically like the static websites and also to an extent the dynamic websites are pretty straightforward to kind of protect against, whereas APIs is a little bit harder. And specifically B2B APIs is the hardest one. That's the industry we are in. So that's why we had to kind of create a custom solution to work around the limitations of the other tools and use our own custom tool. So next slide, Sandesh. So just explaining how whenever you make a request to api.razorpay.com and when you're trying to make a payment, the first request, the very first box it goes to is the application load balancer, the AWS application load balancer, and then it goes to our own custom API gateway, which is based on Gong. So here we have a bunch of plugins around rate limiters, CAPTCHA, and so on. And then finally, once the rules are evaluated here, it goes to the end microservice, right? So this is basically, how the system has been set up. So we do have a web application firewall and the AWS shield set up at the ALB layer itself. So the web application firewall, you have two weapons. One weapon is you can basically throttle it or rate limit it, or the other one is you can block based on a bunch of parameters, right? IP could be one parameter, root could be another parameter, or you could say merchant, which is basically our customer as another parameter, and so on, right? So you can say, okay, for this particular context, go rate limited or go throttle, right? So that's basically what you pick up. Next slide. So we use the API gateway to its complete strength, where it understands the context of every particular request, right? So what do I mean by context? So it understands which route it's making a request on, which merchant is making a request on, and who's the customer that's trying to make a request, right? So based on all of these, we have complex rate limits that can be set up, and we've set it up. So this is where the blocking starts happening, right? And think of the API gateway as the box which does like most of the business logic, and it starts blocking, right? And also API gateway is, we hook it up with our analytics platform where we send all of the events in. So we also have, a Lambda script which tries to constantly read the data and, do some data science algorithms on it to provide rate limits for the context, right? So I'll get to that in a minute. But basically, taking a step back, we have the AWS WAF and the AWS Shield set up at the ALB, and then we also have the API gateway. So coming back to the three-step process for every event, right? So one is detect, prevent, and mitigate, right? So in the detection phase, AWS Shield sends us an alarm anytime there's a DDoS attack. There are three kinds of alarms based on which anytime it sees an anomaly, it sends an alert. So we hook up to that alert, and we've also written our own custom alert because we understand the context better, and we have our data platform which can provide us like alerts whenever even there's a small spike, right? So we have two kinds of alarms coming in there. And specifically on the prevention phase, we have the rate limiter that comes in at the API gateway level, and also we have the CAPTCHA phase specifically for that side. So whenever there is a DDoS attack, so the phase one, we understand what the context is, that is which merchant is under attack, which IPs are attacking, which particular URL path is being attacked. We understand this context. We figure out what the rate limit needs to look like. So this is where the data science algorithm comes in. Based on historical patterns, it would have predicted what the rate limit needs to look like. Pick two of these parameters up, and the Lambda function goes and adds a rate limit dynamically at the box. So there's automation set up to go add a rate limit dynamically at the box. So that way, the majority of the traffic gets blocked at the box, right? So that's basically our architecture end to end. And this has been pretty successful. And we have our own simulations. Our chaos team run simulations to kind of help check against all of these scenarios. So that's basically, our DDoS solution in a nutshell. Back to Sandesh.
Okay. Thanks, Ashwath. So so we spoke a little bit about DDoS. We also spoke, about data exfiltration. We just want to kind of wrap it up by kind of, talking about a few lessons that we learned and which have helped us, formulating the strategy in general. Is the first one, I think this was kind of the most obvious to us, like about a couple of years ago when we started building out these programs, is that at scale, automation is really the only way to solve problems, right? No amount of manual controls, scaling teams, etc. Human assistance can really help in a company with such massive scale, right? So automation is your go-to there. Second is that as a corollary of that is that automation can have unintended consequences, right? So Ashwath spoke about, for example, getting a list of bad IPs from your threat intel, but you don't want to go ahead and directly block it because if you get a good IP which was wrongly tagged as a bad IP and then you block it, then that's a real problem. So it's automating, but also understanding that hey, blocking IPs is a very heavy is a very heavy hammer and should not be used everywhere, right? So we should be aware. We should be aware of the consequences or the unintended consequences of automation, and kind of watch out for that when you build it, right? Which kind of brings me to the third point, is that out of box solutions don't work all the time, right? Like thinking about DDoS, right? We always thought just WAF, right? WAF is a solution for DOS, right? Just block everything at the WAF layer, kind of a thing, right? But that's not true, right? As things scale, things get more complex, and just buying a tool or procuring something or deploying like a system will not help you. You got to kind of think about how do we customize it to meet your use cases. Right. And then finally, incident response in the end, a lot of security is people process technology. We focus a lot on technology today, but people in process are important too, right? So when you talk about incident management specifically, right, you want to kind of have, like I said, you want to prepare for incidents, you want to have runbooks, you want to have on-call teams, you want to kind of figure out how will you respond to incidents and have that play ready even before an incident happens. Right. And finally, ensuring there's a feedback loop between these three stages is really important, right? I think Ashwath explained that really well for DDoS and how each phase kind of feeds off the other. If you have a threat intel system and if you have like a bot blocking system and they don't talk to each other, then you're not learning enough lessons, right? So you want to make sure you kind of connect them, and this also kind of makes sure that your focus is on incremental improvement. There's no value in kind of thinking we'll do everything right the first time. Things will change. So the focus is always on getting better than what we were yesterday, and kind of learning from what we are learning from the data and learning from the mistakes we made. Finally, it really helps to have metrics, to track metrics to drive outcomes, especially in the world of security incidents or incidents in general. MTTD and MTT, mean time to detect and mean time to respond, are really interesting metrics. There are others as well, depending on what area of security you're working on, like defect density and all that. But in general, I think tracking these metrics closely, measuring them, and seeing what's working and what's not working is really helpful, and that can actually kind of help you drive better outcomes. Okay, I think that's kind of all we had. So thanks a lot for joining us today. I know you can reach out to us on Twitter. I'll stick around as well if there are any questions today. So once again, thank you very much. Ashwath, anything you want to add?
Yeah, thank you, Sandesh. Just as an outro, right? There are a lot of solutions that are sold in the market, and they promise to do a lot of things, but just see what actually makes sense in your context, right? And how exactly does it fit into your environment? For example, you can have like the world's best DLP solution, but if you can't integrate it with your DNS resolver, then you will not have a lot of success, right? So just try to custom fit the solution into, or the tool to your solution. And if that really makes sense, that's when you should go ahead and buy it, and that's where you'll derive value out of
it. Okay, thanks a lot, Ashwath, and thanks everyone for listening. Looking forward to the rest of the talks.
Thank you so much, Ashwath. Thank you so much, Sandesh. We have Sandesh here available with us to take questions. That was a great talk indeed. Sandesh, over to you. I think there was a particular question that was asked. The question is, any particular ways that you follow to thwart amplification attacks?
Yeah, I mean, I'm guessing you kind of mean like a DNS amplification attack, right? Is that kind of what you're talking about?
Probably, yeah.
Okay, yeah. I mean, look, I think our focus today on this. So the way we look at it is that DDoS attacks happen at two different layers, right? So one is at the transport or the network layer, which is largely handled by the cloud providers. Right? They do a really good job at kind of managing those attacks on their own. The solutions come out of the box and they kind of work well, right? So where we have focused a lot more is on the application layer of DDoS attacks, because what happens is that all your services don't account for the same volume traffic, right? So every service has a different level of RPS that they expect, right? So when you use HTTP requests to kind of make sure that you send a higher volume, that's when the problem happens, right? And again, so our focus has been not so much on DNS volumetric amplification attacks or other kinds of volumetric attacks, but more on attacks which hit our services, because we expect the cloud providers to kind of manage most of the other things. So yeah, so no specific strategy per se for DNS amplification. Like I said, most of the focus of ours is on the services stuff.
Okay. There's one more question, Sandesh. I think.
Yeah.
Can you talk about approaches towards monitoring access audits? Did you automate them? is the next
Yeah.
question.
Yeah, so I mean, I don't want to talk too much about exactly what we do and stuff, but at a high level, right? I think access audits come at, in various shapes and form, right? So I think the way I look at it is that, like I said, right, so there are two different levels of access audits. One is about who has access to what. So the access management can get stale over time, right? So whatever approval processes you have, etc., they're kind of bound to be, misused or abused. Not on purpose sometimes, but because there's an urgent business need, approvals go through quickly, and so on and so forth, right? So one thing is to kind of do a cleanup every now and then to make sure people who have access have access, and you do other things like provide temporary access, glass break access, and so on and so forth. But the other one, which is really important, is to kind of figure out, even once somebody has access, figure out how often they access, right? So there are open source tools available out there which kind of monitor certain. So for example, there are it monitors certain kinds of queries, right? So if somebody, if like a data analyst is doing a select star from on a critical table, that sounds odd, right? That's not a typical use case for a data analyst, right? So you want to kind of be able to kind of like configure some of those requests, which can give you a large dump of data, which is not useful to a human, and then kind of manage and then kind of monitor for that, right? And whenever that alert comes up, then you go and kind of take a look and see what happened there, and so on and so forth. Problem with a lot of these monitoring is that it leads to a lot of false positives. So over time you got to kind of tune your tool. That's on the human side of it, right? As far as access audits, monitoring access audits from application to application level, like service to service calls, etc., that's a lot more complicated and really depends on your architecture, right? So for example, if you are a company which uses like a service mesh, then monitoring access audits is very straightforward. It's actually like super simple. The service mesh will actually give you all the features to kind of do that for you. And it also maybe, it'll be very simple to set up like alerting. On the other hand, if services talk to each other based on like basic auths, right, then you have to like really do a lot of, automation to kind of even figure out who has access, which service has access to what service, what level of access should it have, how do we track it? It becomes pretty hard. And then, you'll have to rely on the applications themselves configuring it the right way. So I would say there's no simple answer to that, but in general, one is monitoring, who has access to what in a user and service space, and second is that what did they actually access and how often do they access. So those are the things you should try and answer. Hope that answers the question. Last question, when Ashwath said find out the API calls which are more prone to getting called by a hacker, what criteria do you take into consideration? Okay, cool. Yeah, so this one's really interesting, right? So to give you a little bit of background of how things work at Razorpay, again, very context specific, right? Is that Razorpay has merchants, which are companies who integrate with us, and then those merchants have customers, right? So when you make a payment to one of our merchants, you are the customer. The merchant you're paying to is our merchant, and then we have Razorpay itself. So there are two different kinds of calls we can think of, API calls we can think of. One is what we call as client to server calls, which is the customer makes a call to Razorpay API, right? Razorpay endpoints. So this can be like your checkout API when you're making a payment, and then there are S2S calls, which is our merchants making a call to us, right? So this may be to get a list of all the payments that happened yesterday, to make a configuration change, and so on and so forth. Now, for us, the higher chances of DDoS attacks happen on, for example, the calls made by customers, right? So because for that, you don't have to be onboarded as a merchant to Razorpay. So additional controls like KYC, etc., don't apply there, right? So for our business use case, we are very clear. The number one attack vector for us is checkout APIs or other APIs which are used by the customer, right? So that was our first thing that we worried about, right? So that was most prone to a hacker kind of exploiting it. The next one was, S2S calls. Now, bear in mind, given we are like a SaaS business, all these calls are public, right? They all come from the public internet. But there are different levels of authentication behind each of them, and therefore the ones where there's no authentication or like free signups and things like that, that's what would be most prone to DDoS attacks from us, because and that's how we look at it. A simpler framework for that would be to say that so DDoS in the end is a money game, right? You have to buy botnets. The simpler your attack vector, the more bots you can buy, and the more the more attack traffic you can send, right? So attackers want to find the easiest API that they can hit you with, right? So if they have to go create merchant accounts, figure out some way to bypass KYC and then send you DDoS traffic, that's too much effort. That's too expensive for them, right? So they try and take the simpler route, right? So the idea is that, think like a hacker, think like how much money they have to spend to do this. And not everybody has millions of dollars to spend, right? And I'm not saying that can't happen. I'm just saying that, your higher probability of using public APIs without authentication is higher. So, obviously framework changes for each company, but if you have to kind of have a generic framework, I would say look at APIs which hit your backend services without authentication. That's one. Second would be with authentication, but simpler authentication, maybe something you can sign up using APIs and you can automate the account creation process. Third would be where account creation requires some kind of manual approvals from your company, etc. There, things are a lot harder, a lot more targeted compromise needs to happen. So that's how I would kind of like rank what APIs are important. Okay. I hope that answers the questions.
Yes, Sandesh, indeed. That's great. Yeah. I think that was the set of questions that we had for today. Thank you so much, Sandesh. I think there are going to be a bunch of other set of questions coming in to the Discord channel as well. So probably, yeah, I think we can certainly take those questions offline. Thank you so much, Sandesh. Thanks a lot. I think it was a great presentation from you and Ashwath. We really thank you for being part of this event. Yep.
Yeah, thanks a lot. Ashwath couldn't be here because he's on a beach, but I'm sure he would have enjoyed being here as well. So thank you for having us.
Sure. Thanks, Sandesh.